fluid coding, and AI. MiniMax M3 has the kind of spec sheet Repo-Agent users want: 1 million tokens, coding agent positioning, multimodal input, and an aggressive price story. But the practical question is sharper than the marketing. Can it actually survive issue triage, multi-file edits, failing tests, messy tool output, and reviewer feedback? The clean way to evaluate M3 is not to ask, does it beat frontier coding models? That would overstate the evidence. The useful question is narrower. If you put MiniMax M3 into the same Repo-Agent pattern we use for other model reviews, does it find the right files, make coherent changes, repair tests, recover from bad tool output, and handle a reviewer asking for one more fix? By the end, the decision should be practical. Test it, use it for cheaper first-pass work, or keep it away from high-risk repo changes. MiniMax announced M3 on June 1, 2026. The headline is unusually dense coding and agentic capability, MiniMax sparse attention, up to a 1 million token context window, and native multimodality for image, video, and computer use style tasks. MiniMax also positions M3 as open weight, but there is a caveat. The launch post said the technical report and model weights would be released over the following 10 days. So unless the weights are verified separately, the safest wording is open weight positioned, not open source. The long context part matters because repo agents do not fail only at writing code. They fail when they explore the wrong files, miss an existing convention, forget a previous command result, or treat a test failure as noise. MiniMax says the M3 API supports up to 1 million tokens with a guaranteed minimum of 512,000 tokens. It also says calls at or below 512,000 input tokens use standard pricing, while longer calls move to a higher long context rate. That is a real product promise. It is not the same thing as a verified ability to use all that context well. MiniMax reports strong first-party results for M3. Its public material says M3 reaches 59% on SWE-Bench Pro, reports BrowseComp at 83.5, and reports PostTrainBench at 37.1. MiniMax also describes long autonomous examples, including a roughly 12-hour paper replication run with 18 commits, and a roughly 24-hour CUDA optimization run with 1,959 tool calls. Those examples are useful evidence that MiniMax is aiming at long-horizon agent work. But they are vendor-reported. They should start the evaluation, not end it. DeepSWE is the benchmark that makes this review interesting. DataCurve published it on May 26, 2026. It contains 113 original long-horizon software engineering tasks across 91 active open-source repositories, covering TypeScript, Go, Python, JavaScript, and Rust. DataCurve says the tasks are written from scratch, use behavior-focused prompts, and are scored by handwritten verifiers. That matters because the benchmark is trying to test repo behavior, not whether a model can imitate a known pull request. MiniMax M3 was not in the official DataCurve rows I found, but an independent run put MiniMax M3 through the unmodified mini-swe-agent loop on DeepSWE using the MiniMax Anthropic compatible provider, API, and modal sandboxes. The strict result was 13.3% pass at 115 of 113 tasks. With an extended cap, it reached 16.8%, or 19 tasks, but 4 of those passes were over the strict working time budget. That is the number to keep scoped. MiniMax M3 through mini-swe-agent on DeepSWE. For the frontier comparison, GPT 5.5 is the clean DeepSWE leader in DataCurve's published table at 70%, plus or minus 3. Claude Opus 4.7 is also a premium coding agent reference at 54%, plus or minus 5. For the cheaper or open-ish baseline, Kimi K2.6 is the strongest candidate from the same table at 24%, plus or minus 2. That makes the contrast blunt. In this specific harness and task set, the independent M3 run is far behind GPT 5.5 and Opus, and Opus, and Opus, and Opus. The case for testing M3 does not disappear just because the strict score is weak. The independent run reported many failures that were not total misses. Among 94 non-passes, 35 were near misses with at least 90% of new behavior tests passing, and the median failed attempt still passed 79% of new tests. That pattern matters for real teams. A model can be a poor autonomous finisher and still be useful for cheaper first-pass triage, bulk repo reading, draft edits, or low-risk chores where a human review step is guaranteed. So, the practical review pattern should stress the agent loop directly. First, issue triage. Does M3 locate the actual fault or wander because context is cheap? Second, multi-file edit. Does it preserve local style and contracts? Third, test repair. Does it interpret failures or patch around them? Then come the agent-specific parts. Tool output recovery tests whether it handles timeouts, truncated logs, noisy installs, and failed commands. Reviewer feedback tests whether it makes a surgical follow-up change instead of rewriting half the solution. My current verdict is cautious. MiniMax M3 is worth testing if you care about long context, provider-direct experimentation, and cheaper agent throughput. It is not yet something I would rank near GPT 5.5 or Claude Opus 4.7 for high-stakes autonomous repo work based on the evidence in this research. The fair interpretation is this: MiniMax has a serious product promise and some strong first-party claims. DeepSWE, under a neutral mini-swe-agent harness, gives a much colder signal. The practical value depends on whether its misses are cheap and reviewable. If you want more practical Repo-Agent reviews like this, like the video and subscribe to Fluid Coding and AI. The useful question is rarely who wins a headline chart. It is which model you can trust with your repository, your tests, and your review loop.